In the second problem, we have a bullet leaving a gun. So a bullet travels the length of the barrel in 8.10 times 10 to the negative 4 seconds. That's about 0.8 milliseconds. Accelerating at 6.2 times 10 to the 5th meters per second squared. Now, what else do we know? Well, the bullet is initially at rest, so you pull the trigger. V naught then is 0. Now, we want to know what the final velocity of the bullet is as it exits the barrel. So, well, the definition of average acceleration leads us through a few steps to acceleration is change in velocity over change in clock time. And I took the liberty of writing delta V as Vf minus V naught. But you got to be careful that you connect this all the way back to the definition of acceleration as the average rate of change, or the average acceleration is the average rate of change of velocity with respect to clock time. Okay, so, well, it's this, and since the initial velocity is 0, we have Vf over delta t. Vf minus 0 over delta t is just Vf over delta t. And then it follows, since the acceleration is Vf over delta t, that Vf is the acceleration multiplied by delta t, and we can just plug in our acceleration and our delta t, do the calculation, and we learn that the bullet exits at about 500 meters per second. Now, next problem. We have motorcycle. Motorcycle accelerates from rest to 26.8 meters per second in 3.9 seconds. So our final velocity is 26.8 meters per second. Our delta t is 3.90 seconds. And our initial velocity, of course, since we're starting from rest, is 0. Then again, definition of acceleration, yada, 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 gives us this. I actually just say yada, yada, yada. I didn't even watch that show. Okay. Not even completely sure which show, but I think I know. Okay. Acceleration, as before, is Vf minus V naught over delta t. Again, reasoning carefully from the definition of acceleration up to this point. And we do the calculations, which are identical in form to the calculations we did here. And we easily find that that's going to be an acceleration of 7 meters per second squared. Now, we're also asked, how far did the motorcycle travel? So, what do we know? Well, we know V naught and Vf, and we're assuming a uniform acceleration. That's not completely accurate, but that's our approximation, our assumption in this case. So we're going to be able to determine from the straight line property of the real line, of the V versus t graph, what the average velocity is. We just average the initial and final velocities. We get the average velocity. And then our definition of average velocity tells us the average velocity is delta s over delta t. So that, okay, well, we get this for our average velocity. And since average velocity is delta s over delta t, then delta s is average velocity multiplied by delta t. We multiply our average 13.4 meter per second motorcycle velocity by the 3.9 second time interval, and we get approximately a 53 meter displacement. Okay, so the acceleration will take place in about half a football field. Okay, a little over half, 56 meters roughly, 57 yards roughly. So there's our result.